it working? Excellent. All right, so systems of inequalities, here's how they work. They work just like about a week and a half ago, we was graphing just simple inequalities. Look something like this. Like you went over, graphed a line, and it was either dotted or solid. You picked a test point and you shaded on the side that's true. You remember this? Stuff like that. Yeah. Same thing. It's just we're doing it twice. That's the difference. Now let me ask you this in this context. What does the dotted line mean?
The circle is empty.
The what? You're right, but I didn't hear all what you said. I heard only a piece of it.
That the circle is empty, you don't fill it in.
Okay, what kind of symbol is that?
Wait, the circle is dotted?
A line underneath the inequality.
So okay, so
there's a line that's solid. There's not a line that's dotted.
yeah. I know when she said empty circle, you were associating this with that. But what I was looking for was what you said, the inequality. Yeah. What did the shades all represent?
The solutions that are true.
Yeah, so I'll pick any point in here, I'll plug it into my inequality, and voila, it works out, right? So the only difference with today's is you're putting two of them on one graph, and I only really care about the shaded areas that overlap each other. That's really all I care. So let's look at number one together. I'll do one with you as an example, then I'll turn you loose. All right, so the first inequality here. What form is it in? So we pretend it's just an equal sign for a minute, right? Where do I start graphing it? Okay. Yep. What's my slope? Mm-hmm. So from this point, how do I move? Okay.
Up to
To the left. 1, 2, 3. Why am I going back left? Negative, because the line should do this, right? So it's positive 2, negative 3, so that makes it, okay. Should I have a solid or a dashed line? Solid, because they're equal to 2, right? So, how do I determine which side to shade? Plug what in? Okay, give me a random number. Yeah, that's a good one. 0, 0. So negative 2/3 times 0. 0. So basically, it goes away, right? Is 0 less than or equal to negative 1? No. It's bigger, isn't it? So I shape them. There you go. So try to be neat with your shading. Don't be like all over the place, because you'll be looking at this later for studying or whatever, and you won't be able to make heads or tails of it if it's sloppy, because there's a lot of shading things going on here today. All right, so took the first inequality, I graphed it, I shaded it. Now I'm going to move on to the second. That would be my advice for doing these in general. Don't try to graph both the lines then go through the shade, because it's going to get all muddled and you're going to get confused. So the second one, how do we graph? Negative 8. At the bottom. 1, 2, 3. Oh, at the very, very bottom. Okay. Slope?
Up 1 over to the right.
To the right too? All right. I'm going to do a couple more just make sure I get my line right. Should it be dashed or should it be solid? Solid as well, right? Because of this inside. All right, so we'll use that point 0, 0 again to shade with this side or this side. So true or false?
True.
The 0 is bigger than negative 8, right? So now, before you start going crazy on your shading, remember, I only really care about the shades where they overlap. You know, obviously this line will shade over this as well. But really, if you want to just try to keep your graph neat, this cross-hatched area, that's really all I care about. So if you wanted to make it a little bit neater on your graph, you could erase that little bit down at the bottom. Because it's only just going to be that spot. That's it. You're done. So where before with the equations, where they intersected, that one point was the only point that gave a true solution. If we graphed it right, I should be able to pick any point in here and it worked. So give me a random point in that area.
-4, -4.
-4, -4? Okay. So -4, -4. So that'd be a positive 8/3. That's what, 6. That's gonna be 2 and 2/3. 2 and 2/3 minus 1 will make it 1 and 1/3. Is -4 less than 1 and 1/3? 2/3. So it checks out. Let's check it on this one. Oh, that'll work out nice. Half of -4 is -2. Is -4 greater than -10? So I took some random point in here, I tested it, and it worked out for both. That lends itself to letting you know that this shaded region, that's your solution set. That's it. So your assignment is this. It's those other remaining, what, 5? Is it 5 of them? Yeah. Is to graph those. Be careful, about signs. Be careful about, whether dashed or solid line and your shading. And you just go find the shaded region. That's it. Cool. That is our assignment.